have to move on. So the next talk will be on monsoon simulations on GFDL HiRAM. Will be given by Dr. Chi-Hua from Academia Sinica.
Good afternoon. The goal of this study is for exploring the current and the future monsoon climate. And current focus is on the Asian summer monsoon, and the GFDL HiRAM model is used. I would like to acknowledge our modeling group to prepare the model output data. I'm going to show you the first for the present day monsoon simulation, and then the global warming impact. These are the data to be available for analysis. And first, we have two high horizontal resolution model output, and for the historical one for HiRAM model and one for the MRI. And we also want to compare the HiRAM in a 50 kilometer horizontal resolution compared with the CAM5 coupling with the stable ocean model result. But the data available is running for a CESM pre-industrial result. We have 40 years model output, and the final 20 years average was analyzed. And in the future, we will also compare the model data from the HotGen CGCM. It also has a 50 kilometer historical run. And I will also want to show you the CAM5 model output based on the 50 kilometer and 100 kilometer, and coupled with the stable ocean and the prescribed SST. And for the future climate change, I would like to show you the MRI result as well as the HiRAM 20 kilometer resolution and the 50 kilometer resolution. And in the future, we also have the several model output for different SST forcing. Satellite data for comparison include precipitation from GCP and the TRIN with horizontal resolution quarter degree and 1 degree respectively, and also compare with the dynamical field to the NCEP analysis 1. To investigate the Asian summer monsoon, it's common to separate two more subseasons. In the early summer, generally in the current climate from mid-May to mid-June, corresponding to the developing phase of the largest scale Asian summer monsoon, which corresponds to the monsoon onset over the Bay of Bengal and pre-Meiyu and the Okinawa Baiwu front in East Asia. And in the late summer, it corresponds to the North Pacific, corresponding to the monsoon onset over the WMP, the Meiyu and Baiwu front terminate. Here I show you two satellite observation and from TRIN and GBCP. And the TRIN have a higher precipitation intensity compared with the GBCP precipitation. So for a specific region for a precipitation time series, here show you the three region for precipitation evolution from May to August. So you can see a very clear timing of the precipitation from early summer to late summer. And the evolution of precipitation is highly related to the evolution of the Western North Pacific high evolution. So generally you can see the earlier precipitation season in East Asia and then in the Western North Pacific. And for more specific precipitation in Korea and Japan, you can see the precipitation, the timing of the precipitation season is a little different compared with the other region. And this is the observation. And now I show you the result model output from the HiRAM 50 kilometer and 20 kilometer. So generally, I will show you the correlation coefficient later, but here you can see the general time series of the HiRAM simulated precipitation. So particularly for the East Asia precipitation, the model cannot better reproduce the current climate over the East Asia region, as well as over the WMP, the HiRAM, either in the higher, in the 20 kilometer resolution or 50 kilometer resolution. The strength of the WMP monsoon is overestimated. The monsoon over this area is also simulated much earlier than the general in the observation. Generally, it occurred, onset occurred over the mid-July to late July. This is the MRI result. It could be one of the best. Okay, almost the best for the MRI have the 20 kilometer resolution, so it could simulate better precipitation evolution over East Asia, as well as over the WMP. Here show you another 3 model output from the CAN5 with prescribed SST and the slab ocean model coupling. And you can see generally the CAN5 can also duplicate the current climate of the East Asia monsoon precipitation, including the seasonal evolution of the WMP monsoon. How about the correlation coefficient? This is just a very simple method to calculate between 2 time series compared to the observation. Okay, generally, higher horizontal resolution can have better simulated precipitation, a higher correlation coefficient. We compare between the HiRAM and the covering with the ocean covering. The model can also have a better performance of the monsoon precipitation. Okay, for more detail for the East Asian precipitation, this is the observation from the GBCP and much higher resolution from TRIN. And the cross-section over East Asia here. So this is from the April to September, and this is latitude band. Here show you the spring rain and pre-Meiyu and Okinawa Bayou, as well as the South Asia monsoon onset around mid-May, and the mature phase of the Meiyu and the Bayou, and corresponding to the onset of the WMP monsoon, the Meiyu and Bayou break. So generally, TRIN have a higher intensity of the precipitation when compared with the GBCP result. Couple model can generally simulate the good performance for the East Asia precipitation, but a higher horizontal resolution can have a better performance for example, the South China Sea monsoon onset and the strength and the evolution. The AGCN, this is the CAN5 with the prescribed SST with 100 kilometer resolution. So generally, it has a weaker WMP monsoon when compared to its slab ocean couple version. And this is the MR result. You can clearly simulate the 2 periods, at least the 2 periods, and the strength of the WMP monsoon. And the HiRAM results show you here. This is the 50 kilometer, and this is the 20 kilometer horizontal resolution. So generally, you can see the higher resolution can have better precipitation evolution and strength over East Asia area. Now let's focus on the HiRAM result and compare between the 50 kilometer and the 20 kilometer. So this is the early summer, which the major feature is the Meiyu Battlefront and the monsoon over South Asia. So as you can see here, this is the model output minus observation. The GBCB data is used. So it generally underestimated the precipitation in the Meiyu Battlefront and overestimated the WMP monsoon. And the same model bias occurs in 20 kilometer, but these things can have a lot of considerable improvement. For example, the underestimated can be improved in a higher resolution. This is the 20 kilometer minus 50 kilometer. And over the WMP, okay, the bias seems to be improved. And in late summer, the major feature can be focused on the WMP monsoon. So generally, the HiRAM 50 kilometer and 20 kilometer overestimated the WMP monsoon. This corresponds to its earlier simulated monsoon onset over the WMP. And also we can see some improvement from the 50 kilometer to 20 kilometer over the WMP. Previous slide show you the precipitation result, and here quickly show you the thermal and dynamical conditions. This show you the surface temperature and sea level pressure. So in the 50 kilometer simulation, HiRAM have a very strong monsoon trough, monsoon low over the WMP, and also some simulated pressure bias over the North Pacific. But the model bias seems to be improved when the horizontal resolution can be higher. And the more detail for the circulation feature, we can see, for example, the blocking effect over the south flow of the Himalayas and Tibetan Plateau. This is the westerly jet and the easterly jet combined. You can see upper level anticyclone circulation and the southwesterly monsoon over South Asia and the upward motion over the plateau. So the model in a 50 kilometer horizontal resolution, some model bias can be improved, but the improvement not occur everywhere. So you can see some improvement, particularly over the South Asia monsoon area as well as the Tibetan Plateau. Very quick, show you the some monsoon index. This is the South Asian high. Show you the cross section along this latitude band, and this is time series. So generally, you can see the upper level high develops and reaches its mature phase in mid-June to mid-July. And corresponding to the evolution of the upper level high is the development of the WMP high as well as its stagnant phase. And our blue line show you the corresponding change of the monsoon trough. This is the WMP monsoon index identified by the lower level westerly wind. And so corresponding to the onset of the WMP monsoon is the northward shift of the WMP high and the weaken of the high. And the timing of the upper level jet over East Asia, the change of the jet have the corresponding timing of the WMP monsoon as well as the upper level high. This is the reanalysis data. And this is the 50 kilometer HiRAM result. So generally you can see the good performance for the circulation feature. However, you can also see the stronger WMP monsoon and the earlier timing of the monsoon simulation. When the horizontal resolution can be higher, you can see some improved for the WMP high, but the monsoon is simulated too strong, and the timing is not correct. The couple model can actually have a better performance of the WMP monsoon. For example, you can see even in the 100 kilometer resolution, coupled with the stable ocean, the CAM5 result is similar to the previous one. This is the unseparate analysis. So the strength of the WMP high the WMP high should be stagnant in the midsummer. Okay, you can see the good performance for the couple model, and the resolution, higher resolution in the CAM5 can also simulate the WMP high, the strength of the high. And let's show you the MRI result and compare it to the HiRAM result. So generally, the MRI result can have the HiRAM result. HiRAM over-simulated the WMP monsoon, and the monsoon occurred earlier. So now I show you the global warming impact using the RCP 8.5 scenario. Three model outputs are compared for the 50 kilometer and the 23 kilometer from HiRAM, and this is the MRI result. And this is their RCP simulation. So higher resolution can have better performance. And you can also see the little bit difference between the future climate projection. And this is the MRI result. And generally, you can see in the future climate, under the RCP scenario, the precipitation is might be increased in the mid-latitude and decrease over the subtropical area. And it can be also seen in the MRI result, but a little difference over the WMP. And for detail for the circulation feature, this is the early summer, and this is the historical run, and the RCP minus historical run. The upper panel show you the HiRAM 50 kilometer, and lower panel show you the 20 kilometer. So generally, higher resolution have better performance. For example, you can see the jet stream, the strength is better simulated over the higher resolution compared with the lower resolution, as well as the circulation feature when you compare for a detail. And in RCP scenario, you can find very different result from 50 kilometer compared with its higher resolution version. And these two difference is very different, should be corresponding to the evolution of the Pacific high as well as the upper level jet. You can see at 50 kilometer future climate, the Pacific high has a ridges over the Taiwan area. However, in the higher resolution, in the early summer, the high ridge is still over the South China Sea and the Philippines. This shows you the difference, the change from historical run to the RCP. So I plot these two contour lines to show the stronger Pacific high, and you can see a quite different feature. And in the 20 kilometer horizontal resolution, the stronger Pacific high in the lower troposphere seems to be consistent with the stronger westerly jet. In the current climate, in the early summer, the monsoon evolution is quite similar to this figure. For example, if in 1 year, the westerly wind is too strong, will correspond to the stronger Pacific high. So different circulation feature seems to be reasonable compared with its precipitation change. And then in late summer, you can also see some difference. Either in the 50 kilometer or 20 kilometer, you can see the stronger Pacific high over the WMP as well as East Asia, and the weaker, the decrease of the precipitation over the subtropical area. However, you can see over the tropical area, the future change, the projected future change is quite different in the 20 kilometer compared with the 20 kilometer. And this feature is also, can be also found in the early summer. In the tropical area, the projection is quite different between the two horizontal resolution. So summarize for the circulation result. Here show you the Pacific high cross section for the geopotential high in the lower troposphere, and this is the WMP monsoon trough. So in the 50 kilometer, the difference between the historical run and the RCP run have a very large difference. However, in the 20 kilometer, you can see the difference is smaller when compared to its 50 kilometer version. And particularly show you the precipitation change between over these two areas, one for the subtropical WMP and one for the tropical WMP. And over the subtropical WMP in 50 kilometer, this is time series. You can see the general the decrease of the precipitation, and you can see also in late summer. However, in early summer, the projection is quite different. And the one question might be raised: if you see the simulated precipitation over this area in a 50 kilometer, it has very large difference when compared to its 20 kilometer version. However, during this period, you can find insignificant future change over this area. So different horizontal resolution might cause some significant difference when evaluating the future climate change. Over the tropical WMP, this is 50 kilometer, you can find quite different future climate change over this area. So we are still find some reasonable circulation feature to explore this difference. Okay. The topographically induced precipitation have large influence on the Asian summer monsoon. So generally, we find a better performance of the monsoon simulation when the horizontal resolution can be increased. And using the GFDL HiRAM result model output, we actually found good performance for the pre-Meiyu Baiwu as well as the WMP monsoon. However, the result detail remains unclear and need further study whether the topography associated precipitation can play an important role or not. Okay, thank you.
Okay, any question for Dr. Wu?
The previous study have shown that the onset of the summer monsoon is related to the interseasonal oscillation. So do you evaluate the interseasonal oscillation in this model?
Yes, we actually show some difference between the subseasonal change of the monsoon precipitation. But do you mean the intraseasonal variability or oscillation? Yeah, we actually scheduled to analyze the so-called ISO based on the interannual variability, okay, in different years. But currently, we just focus on the seasonal evolution.
Okay, Marco?
just in terms of your last point there, do you have ideas about how to assess how the topography is making a difference here? So we were just discussing over lunch how to pull apart influences of resolution and influences of orography representation, because obviously the higher the resolution, the steeper your orography, and that can make a difference. That's not quite resolution per se, but it's very difficult to separate the topography and the resolution because they kind of go together. So in your last sentence there, do you have ideas about how you might do that? Could you put the 50-kilometer HiRAM orography in the 23-kilometer model, or vice versa? Do you have some thoughts on that?
Yeah, we actually but find some importance for some critical topography, especially for some mesoscale mountains. The topographically induced precipitation could be very important for the monsoon precipitation. And the topography-induced precipitation might be not very local. It could be also remote, have also remote effect. So we believe, based on this result, if the model can have a more realistic simulated topography associated precipitation, the monsoon circulation might be simulated better. But I have no idea if actually even in the 50-kilometer resolution, many mesoscale mountains can not be very realistic in the model. So, but even the model resolution can be higher without better parameterization. I'm not sure the result would be much better. Okay.
Any other questions? Yeah, I do have a question on this result. When you're using one particular round and looking in the future change, when you said it's passing a statistical test, even for some regional mean and sub-seasonal scale rainfall, is that really the case, or how is this test is done?
The result I have shown you is based on 20 or more years. So the significant test is based on that, and more data might be available in the future.
Okay. Yeah, because I'm just wondering, sometimes even additional member in that sense can be different in a sense.
Yeah,
so I'm just wondering, will that really the signal you can find from these simulations? Okay. Yeah. Any other question? If not, we will have a tea break for 20 minutes, and then continue the same topics. And I will thank the three speakers on the section.